Hi Achievers, guess who's back? Achieve Maths, and we've got a paper for you. It's the GCSE 9 to 1 levels that's been requested. This is a paper from Pearson Edexcel 2017 on the 25th of May. As I said, my name is Achieve Maths, and I'm hoping to be posting some more content for you guys, so subscribe and like. Let's get started. Question 1. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns in one day. And we've got a graph to show what's going on. Maximum temperature on the vertical axis and number of hours of sunshine on the horizontal axis. One of the points is an outlier. Part A. Write down the coordinates of this point. Well, an outlier is a point that doesn't particularly fit with the rest of the data set. So I've just highlighted in yellow the data, and then we've got this guy on its own over here. So the one out on its own is not with the general trend, and that is the outlier. Write down the coordinates. Well, you might remember you go along the corridor before you go up the stairs. That is one way to remember coordinates. Or really at higher level you should be thinking x coordinate is horizontal and y coordinate is vertical. X comes before y in the alphabet, so xy is how you write a coordinate. So let's read off the graph to see what our answer is. So the horizontal, just reading down, between 9 and 11 is 10. And the vertical, between 18 and 20 is 19. Part B. For all the other points, write down the type of correlation. Okay, well, I've kind of drawn the line on. What you would actually do in your exam is get your ruler and you'd be drawing a nice straight line through all the points. And this is called a line of best fit. The line that best fits with all your data. Okay, and you kind of want the same number above the line as below, and it has to go through the middle of your data. So something like, okay. Right. So the type of correlation. Well, if you look at what's going on, the temperature is going up, okay, straight up, and the number of hours of sunshine is going up. When they're both going up, we call it positive correlation. If one was going down as the other was going up, we would call it negative correlation. So the answer here is positive. Moving on. On the same day, in another British town, the maximum temperature was 16.4 degrees C. Estimate the number of hours of sunshine in the town on this day. Now, that line of best fit that we've just drawn on is going to come in very useful here. So 16.4 as the maximum temperature. Go to your maximum temperature scale. Remember, each big square is 1 degree C, and it's split into 5, so each little square is 0.2, so 16.4 is here. Now if we read across until we get to our line, and then read down to get our answer for the number of hours of sunshine. So it's between 12 and 13, and it's 4 little squares across, so that's 12.8. So the number of hours of sunshine you would expect if you had a max temperature of 16.4 degrees C, on average is about 12.8 hours. So let's write that down. A weatherman says temperatures are higher on days when there is more sunshine? Does the scatter graph support what the weatherman says? Well, we were talking about the positive correlation, and as the degree C, max degree C, was going up, the number of hours of daylight was going up as well. And if you think about real life, in winter you have short days and the maximum temperature isn't very high. In summer you have longer days and the maximum temperature is higher. Okay, so yes, it does support it because both are going up. So more days, more hours of sunshine is associated with a higher max temperature. For instance, looking back at the graph, if you're up at the top end, you've got a higher max temperature here, and you've got higher number of hours. If you're down at the bottom end, you've got a lower max temperature and a lower number of hours of sunshine. Question 2. Express 56 as a product of its prime factors. Right. We don't want to get too technical, but any number that you can think of, you can split it up into prime numbers multiplied together. And there's only one way to do that. Now, if you know your times tables well, you might know that 8 times 7 gives you 56. Or if not, don't worry, you can just say 2 times by 28 gives you 56. I'm showing two ways. You wouldn't have to do this in an exam because I want to show you how it can still work both ways. Now 8 is 2 times 4 and 4 is 2 times 2. Now once you can't split them up anymore, hence when you get to prime numbers, that's your answer. And if you actually multiply these guys together, you will get 56. You can try it on a calculator or in your head. 2 times 2 times 2 times 7 will give you 56. Another way to write 2 times 2 times 2 is 2 cubed times 7. Now, back to what I was saying. If we didn't know that 8 times 7 was 56, no panic. 2 times 28. Can't split up 2 anymore. And by the way, it doesn't count doing 1 times 2 because you don't want to use 2 again. We've already got the 2. 2 times 14 and 2 times 7. Look guys, as promised, same numbers. Question 3. Work out 54.6 multiplied by 4.3. Right, quite a tricky multiplication question. All around the world there's going to be very many ways to do this question. Now, one of my favourite methods is actually called the Chinese lattice multiplication method. So that's the one I'm going to show you, and it works quite nicely when you've got decimal points as well. If you haven't seen this method before, it's going to look really weird. If you have, you'll know what I'm doing. I might do a separate video on this if enough people request it, but let me show you how it's done. So it's a 3-digit times by 2 digits, so we've got a 3 by 2 grid. Let's write up our first number, 54.6, and then let's write up our next number, 4.3. Now we are going to multiply in the grid each number by itself. So 6 times 4 is going to be 24, but the method requires us to split it up into 2 and 4. And we actually split our grids up to do this method too. So you draw diagonal lines through your grids this way, through every single one, and at the top of your grid you've got your tens, okay, and underneath you've got your units. So let's get down to business. 6 times 4, as we've said, is 24, and we write it 2, 4. 6 times 3 is 18, 1, 8. 4 times 4 is 16. 4 times 3 is 12. 5 times 4 is 20. 5 times 3 is 15. Now what we do is we go along each diagonal and we add up those numbers. Okay? So first one, all we've got is the number 8. So we're going to write that down. The next one, we've got 2 plus 1 plus 4, 7. 2 plus 6, 8 plus 1, 9, plus 5, 14. So 4, carry your 1. 1 and 1 and 1, 3. So our numbers are 2, 3, 4, 7, 8. Now, do not forget your decimal place. This is where it could get a bit tricky, but let me show you what to do. Follow your decimal place down, follow your decimal place across, and where they meet, take it down. That's where your decimal is going to go in the answer. Okay, so we've got, reading it this way, 234.78. I think that's quite a nice way to do it. I hope you agree. So let's chuck our answer where it should be. Question 4. The area of square ABCD, that just means ABCD makes a square, is 10 centimeters squared, this whole area. Show this equation. Let's think about it. So, square, we're going to get the area by this multiplied by this. And because it's a square, that means that the base and the length are the same. Okay, so you've got 3 up to here, and then you've got x from here to here. So in total, that's actually 3 plus x. Now because it's a square, the other side is also 3 plus x. So what we want to do is we want to multiply this by this to get the area. Now, because it's something adds something else, and we're trying to multiply, you need brackets to keep it together. So it's 3 plus x times by 3 plus x. Now you can have the little bracket there, the little multiply, or you cannot, it doesn't matter, okay? You could just put the brackets next to each other. Now there's many ways to multiply this out, you just need to make sure everything here is multiplied by everything here. So 3 times the 3, 3 times the x, x times the 3, x times the x. I draw it this way and have a little half moon going on. I do have a video teaching this method if you're not sure. So let's get started. 3 times 3 is 9. 3 times x is 3x. X times 3 is 3x. X times x is x squared. And they're all pluses. 3x add 3x gives you 6x. So actually the area of that rectangle in algebra is 9 plus 6x plus x squared. Now we're told that the area is also 10 centimeters squared. So we can say equals 10. Now, we want to make it look like this. And we're not quite there yet. We've got the 6x, we've got the x squared. So to make it look like this, let's take this 9 away. So minus 9 from both sides of the equation to keep it fair. And then you get 6x plus x squared equals 10 minus 9, which is 1. Now, it doesn't matter if you write x squared add 6x or 6x add x squared, they're the same thing. So we've proved it. Moving on. Question 5. This rectangular frame is made from 5 straight pieces of metal. 1, 2, 3, 4, 5. The weight of the metal is 1.5 kilogram per meter. So, work out the total weight of the metal in the frame. Now the guys that are going to be easy to find are these ones. Because if this is 12 meters, which it is, then that means this is 12 meters too. And similarly, if this is 5 meters, which it is, then that's 5 meters too. Okay, so we've got 2 lots of 5 meters and 2 lots of 12 meters. So that's 10 plus 24, 34 so far. Now we need the tricky one. We need to find this diagonal. Can you see that as well as being a rectangle, this is also a triangle? And the type of triangle it is a right angle triangle. So this should spring to mind something called Pythagoras. So it's 12 across and 5 up. Pythagoras' theorem says if you've got a right angle triangle and the shorter sides are A and B and the hypotenuse, the diagonal is C, then you always have A squared and B squared is C squared. So that means here that 12 squared plus 5 squared equals whatever this is squared. 12 squared is 144, 5 squared 25, add them together you get 169. We want x, we've got x squared, so square root it, and the square root of 169 is 13. So total length is 34 plus 13, which equals 47, and that's meters. Now the question was asking us, work out the total weight of the metal in the frame. Now each meter of metal is 1.5 kilograms. So we need to times 47 by 1.5. That means we want 47 and then another half of it, because this is 1.5. Half of 47 is 23.5. Okay, so add these two together. 5, 7 add 3, 0, carry 1. So it's going to be 70.5 kilograms. That's your answer. 5 marks. Question 6. The equation of line 1 is y equals 3x minus 2. The equation of line 2 is 3y minus 9x plus 5 equals 0. Show that these two lines are parallel. Now, hopefully you've been taught at school that straight lines can be put into the form y equals mx plus c. Now, m and c are just numbers, okay, like 7, 9.1, minus 2.148, whatever, okay, and m represents the gradient, and c represents the y-intercept. So if you have, just a quick lesson, y and x, like we talked about in question 1, then you can have a straight line, okay, and here is where it intercepts the y-axis, so that's your number c, and how steep it is your gradient. Okay, your number m you get from that. Y is up here and x is here. So basically, if you put in an x value here into this equation, it will tell you what your answer for y is here. That's how the equation works. So our top equation, line 1, already has y equals mx plus c. Okay, the gradient is 3. So line 1, we can put m1 equals 3. That's the gradient. For L2, we need a bit more work. We need to rearrange the equation so that it's y equals. So let's get down to it. Let's minus 5 from both sides. And we get 3y minus 9x equals minus 5. Let's add 9x onto both sides. That gives you 3y equals 9x minus 5. Can you see we're getting closer and closer to this target? Now we need to divide by 3 on both sides of the equation to get it in the required form. Y equals 3x minus 5 over 3. Remember, everything here is divided by 3. So that means that our gradient is m, and c don't worry about. So L2 also gradient is 3, therefore parallel. Done. Question 7. There are 10 boys and 20 girls in a class. The class has a test. The mean mark for all of the class is 60. The mean mark for the girls is 54. Work out the mean mark for the boys. Right, mean we keep saying over and over again. Okay, that means add them up and divide by how many. Okay, so let's say MB, or let's keep it simpler than that. Let's say boys mean, it's a bit easier, equals total, so boys total divided by how many there are, which is 10, and we know that the mean mark for the boys, we don't know what it is yet. Okay, so let's call it x, because we don't know yet. Girls mean, so that's girls total divided by how many there are, and there's 20 girls. Okay, and the mean mark for the girls is 54. So now we can actually figure out the girls total by doing 54 times 20. Okay, we're undoing this divide by 20, timesing by 20. So girls total equals 54 times 20. So times by 2 and then add a 0 on. So you get 108 and then 0. Now total mean, so class mean equals, add them all up, so girls total plus boys total. Okay, so 1080 for the girls, and then boys total divided by how many there are. Well, there's 10 boys, 20 girls, that's 30. And that gives you the mean mark for the whole class of 60. So let's undo this equation, rearrange and find out the boys' total now. So times by 30, 60 times 30, there's many different ways to do this. So 6 times 3 is 18, and you've got 2 zeros basically. So 1080. Going to run out of space a little bit, so let's move all these guys up if we can. That might take a while. Okay, bear with me, I'm going to chuck the working out in here for now. So using this equation, 1080 plus the boys' total, let's say BT for short, equals 1800, minus that from that to give you the boys' total of 720. This reminds me of skateboarding days, doing a 360, a 180, and if you're very good, a 720, which is 2 full spins. But anyway, let's not get distracted. Work out the mean mark for the boys. So the boys' total, we now know what it is. It's 720. Okay, so we can check that here. Divided by 10, that gives us 72. Well, the boys did quite well, didn't they? Got 72, the girls got 54, and it brought it to 60 altogether. So 72 is the answer. Question 8. Write 7.97 times 10 to minus 6 as an ordinary number. That just means we don't want this going on. 10 to minus 6. Now, 10 to minus 6, if you know your powers and things like that, means 1 over 10 to the power of 6. And 10 to the power of 6 means 10 times 10 times 10 times 10 times 10 times 10. That's 6 times. So that's essentially the same as dividing by 10 6 times. Okay, now what we're going to do is we're going to use placeholders. So we had 7.97, okay, and 0, 0, 0, 0, 0, 0, and 0, 0, 0. Okay, now we need to move this number. Every time you divide it by 10, you move it 1. Okay, now that's the same as moving the decimal place the other way. So it's essentially, just trying to think the best way to show you this. Move the 7. 1, 2, 3, 4, 5, 6. 7 goes here, and the 9, 7 go here, and all the rest get filled with zeros. So it's 0.1, 2, 3, 4, 5 zeros, and 7, 9, 7. Work out the value of 2.52 times 10 to 5 divided by 4 times 10 to minus 3. Okay, quite tricky. Can we figure out this bit? Can we figure out the actual numbers without the tens for now? So 2.52 divided by 4. To divide by 4, there's a trick where you can do divide by 2 and then divide by 2 again. So let's half it and half it again. So 1.26 is half. Let's half it again. It's going to be 0.63. So this thing here is 0.63, and then the tens we've not dealt with yet. Now your power laws say if you're dividing, you can take away the powers. Okay, so it's 10 to the 5 minus 3. Now a minus and a minus together make a plus. So it's 10 to the 8. So putting that together is 0.63 times 10 to the 8. Now to be in standard form, you can't have 0 point something, it has to be a number here, so we need 6.3. So we actually just made that 10 times bigger, so we used up one of our times by 10s. So our final answer is 6.3 times 10 to the 7. Question 9. Jules buys a washing machine. 20% VAT is added to the price of the washing machine. Jules has paid a total of £600. What is the price of a washing machine with no VAT added? So we're working backwards on this question. It's very important to remember that. Okay. So there was a price, say price, and then you add 20%, and that gives you the 600 quid she's paid. So that means that 120% equals 600 quid. Now we want the price, which is just 100%. Okay? That's going to be what our answer is. So we could work out 10% first, and times by 10 to get 100%. So we've got 120, we want 10, divide by 12. Do that to both sides. So 600 divided by 12 is 50. Okay, times by 10, 500 quid. Now the good thing is we can check this. So let's check. If the price is 500, 20% equals, well, 10% is 50, 20% is 100, so add your VAT on, that's 600, so it's correct. So chuck 500 in your answer, and you know you've got it right. 2 marks in the bag. Question 10. Show that x add 1 times x add 2 times x add 3 can be written in this form. I tell you what, don't get yourself too worried about this question. It looks horrible, but all it means is you want a number times x cubed, add a number times x squared, add a number times x, add a number. So basically, let's just expand these brackets. Now there's 3 brackets to expand. We can start off by expanding the front 2, like we saw before, and then we'll carry on and times that by the rest. So x times x is x squared, x times 2 is 2x, 1 times x is x on its own, 1 times 2 is 2. Remember, all we've done so far is these first 2 brackets. Let's simplify this. So you can add your x's, your like terms. 2x add another x is 3x. So this is actually the first 2 brackets expanded out. We've not touched this third bracket yet, and this is where it gets a bit trickier. We have to now multiply all of this out. So everything in here multiply by everything in here. So let's x squared, oh dear me. Right, and now this 2 times by both as well. So 6 things to multiply out. Let's have a go. X squared times x, this one, is x cubed, which just means x times x times x. Okay, first one done. X squared times 3, 3 lots of x squared. 3x times x is 3x squared. 3x times 3 is 9x. 2 times x is 2x. And 2 times 3 is 6. Now we have to collect like terms together. There's only one x cubed. Can you see how many lots of x squareds we've got? We've got 3 lots here and 3 lots here. So that's 6 lots of x squared. Same with the x's, we've got 9x's plus 2x's is 11x's plus 6. So show it can be written in that form. Okay, well let's just do one more thing to let the examiner know we know what we're talking about. It's 1 lot of x cubed plus 6 lots of x squared plus 11 lots of x plus 6. And we can label how we wanted it: A, B, C, D. The 1 is the A, 6 is the B, 11 is C, and 6 is D. Great. Next question. Question 11. The graph of y equals f of x is drawn on the grid. Part A. Write down the coordinates of a turning point of a graph. Sometimes in maths you can use your knowledge of the English language. Where do you think a turning point is going to be? Maybe it's where the graph turns. Yeah? So this graph's turning here. This graph's turning here. This graph's turning here, you see? So the turning point, go along the corridor before up the stairs, or down the stairs in this case. So it's 1 across and 3 down, minus 3. Write down estimates for the roots of f of x equals 0. Now, just to give you a graphical answer, here we're talking about y equals f of x. Okay? Y equals some function of x. Okay, so this axis is basically f of x. So if we want to find f of x equals to 0, then we're talking about where that line, where f of x is always 0. If we want f of x equal to 3, where it's always 3, where it's always 5, etc., where it's always minus 3. F of x equal to 0 means we want where f of x, this line, crosses f of x equals 0. Okay? So it's those 2 points. Now it's saying estimates because we're trying to read it off a graph. So each little square is 0.1. So 2.1, 2.2, etc., 2.5, 2.6, 2.7, 2.8 is 1. And also minus 0.5, 0.6, minus 0.7. There are 2 estimates. Use the graph to find an estimate for f of x, f of 1.5. So remember we're talking about f of x, okay? Here, guess what x is? It's 1.5. So go to our graph at 1.5 and then read off the f of x line. Okay, so where is it? It's here. See? We want an estimate for it. So it's going to be across here about there. Now they've tricked you on the scale, you see, because here it's going 2 big squares is 1, now 1 big square is 1. So each little square is 0.2, so it's minus 2.8. Here's your answer. Moving on. Question 12. Find the value of 81 to the power of minus a half. You really need to know your power rules here. 81 to minus a half. Now, minus and a power means 1 over the same power. Okay? So, half, without the negative. Now, power of a half means square root. So it's the same as writing 1 over square root of 81. So what times by itself gives you 81? 9. 9 times 9 is 81. It's important to know your times tables. 1 over 9 is the answer. Find the value of 64 over 125 to the power of 2 over 3. So, we can look at the top and the bottom separately. They're both to the power of 2 over 3. So we can write it like this. Now, 2 over 3 can be written as 2 times by a third. Okay? Because it's 2 lots of 1 over 3. So let's look at this guy. It's the same as writing power of 1/3 times 2. And if you know your power laws, I think I did a video on this a while ago, it's the power of a third and then to the power of 2. Power of a third means cubed root. So something times something times something gives you 64. And in the exam, we're not going to give you 2 tricky numbers. Now, if you know that 4 times 4 is 16, you can figure out that 4 times 16 is then 64. So 4 times 4 times 4 is 64, which means cubed root of 64 is 4. We've still got this squared guy. 4 squared is 16. Let's look at the denominator. Let's do the same thing. 125 to the power of a third, and then squared. Right, well, the 5's a clue. 5 times 5 is 25, times 5 again is 125. So it's 5 squared, which is 25. So the answer is 16 over 25. Quite a tricky one. Question 13. The table shows a set of values for x and y. Y is inversely proportional to the square of x. We can write that like this. Okay? Proportional to 1 over it. Find an equation for y in terms of x. Now, if y is proportional to 1 over x squared, that means that the sum number, let's call it k, such that y equals k times 1 over x squared. Now we just need to use some of these values. Let's pick the easy ones, the whole numbers, to figure out what k is. So how about we pick these 1 and 9. So x equals 1 when y equals 9. So substitute these into the equation for y and x. So 9 equals k times 1 over x squared. Okay, well 1 squared is 1. So this is just a fancy way to write 1. So that means 9 equals k, or k is 9. So from this equation, y equals 9 times 1 over x squared. If you want to be doubly sure, let's do a check. Let's check it using these numbers. So, does 1 equal 9 times by 1 over 3 squared? Yes, it does, because 1 over 3 squared is 1 over 9, times 9 is 1. Part B. Find the positive value of x when y is 16. So let's use our equation from the previous question, and we know now to substitute y is 16. This y, we're putting 16. 16 equals 9 times 1 over x squared. We need to rearrange now. Let's times up by x squared on both sides. So you get 16x squared, and now it's gone from the denominator here, equals 9. So x squared divided by 16, 9 over 16. Now, normally here, you would need to say x is plus or minus the square root 9 over 16. But look, positive value, so we don't need the minus, it's going to be the plus one. Square root of 9 is 3, and the square root of 16 is 4. So it's 3 over 4. And that's because we want the positive one. Okay, or 0.75, same thing. Cool. Question 14. White shapes and black shapes are used in a game. Some of the shapes are circles, all the other shapes are squares. So we've either got squares or circles. Some are black, some are white, as far as we can tell so far. The ratio of the number of white shapes to the number of black shapes is 3 to 7. The ratio of the number of white circles to the number of white squares is 4 to 5. The ratio of the number of black circles to black squares is 2 to 5. Work out the fraction of all shapes that are circles. Okay. Now, here we've got ratios within ratios. So white shapes to black shapes is 3 to 7. Okay. So white shapes to black shapes, 3 to 7. Now, ratio of white circles to white squares is 4 to 5. So this is kind of split up. Okay. And 4 to 5. And also, this is split up. Black circles to black squares, and that's 2 to 5. So this is what I mean about a ratio inside a ratio. Now, fortunately, your 2 and your 5 add together to give you 7. Here, though, your 4 and your 5 add together to give you 9. But we're talking about 3 here. So ideally, we would want this to be a 9. Okay? And how did we get that to be a 9? We times by 3. So if we times this by 3, we get 21. And that means that we can split this out. So your 9 is split as 4 and 5. And now we want the 2, 5 to be out of 21. So again, times by 3. So if you do times by 3, 2 times 3 is 6, 5 times 3 is 15. These are now adding to give you the right thing. And the 7, so the 21, is now made up of your 6 and your 15. I hope you're following this because it's quite tricky. So now, on 9 to 21, for white to black, can be written as 4 to 5 to 6 to 15 as one big ratio. And let me just draw a diagram of each one. So your 4, remember, was your white circles. Your 5 was to do with your white squares. Your 6 was to do with your black circles. And your 15 to do with your black squares. So this is all our information all together. The question, work out the fraction of all shapes that are circles. Well, the ones that are circles are the 4 and the 6. So that's 10 out of how many? Well, 9, 15, 30. 10 out of 30, written as a fraction, is the same as 1/3. That's for 4 marks, because there's quite a lot of thinking to do there. Question 15. A cone has a volume of 98 centimetre cubed. The radius of a cone is 5.3 centimetres. Work out an estimate for the height of the cone. And it's given as a formula, that's nice. This used to be a formula given in the older style exams as well. So the height of a cone, this isn't the best drawn cone I know, is from the base up to the top. Okay, and that's our height. We don't know what that is. We do know the radius, which we use as r. We do know the volume, which is 98. So let's write out what we know from our equation. 98 equals 1/3 times pi times r cubed, which r is 5.13, squared, times by height. Now it's a shame we don't have a calculator to bungle this into. We need to do 5.13 squared, but it's saying estimate. Now when it's saying estimate, we can generally round to about one significant figure. So let's round. So 98, let's call it 100. 1/3 can stay the same. Pi, if you put it in your calculator, if I can remember correctly, 3.141592 and then 56 maybe, something like that. But we're estimating, we don't need this many significant decimal places. Pi, interesting fact, does actually go on forever. So we could actually use 3 to make a quick estimate, make our life simple. It's always good to do. So let's use 3 for pi. Let's use 5 for 5.13, and then height is what we're estimating. So 1/3 times 3, they cancel out. 5 squared is 25. So 25 times the height gives you 100. Divide by 24. 4 is the height, 4 centimetres. Estimate. John uses a calculator to work out the height of a cone to 2 decimal places. Will your estimate be more than John's answer or less than John's answer? Okay, so let's think up here what we estimated. We estimated the 98, we estimated the pi, we estimated the 5.13. If we want an equation for h, then it's h equals volume of the cone. So volume times by 3 divided by pi r squared. I've just rearranged this formula up here. Now, volume went up a bit, pi went down when we estimated 3 from 3.1415, etc. And r went down. Okay, so rounded, vol went down, pi went down, and r down. Okay, so the numerator higher and denominator lower implies we got higher number. Okay. So will the estimate be more? So it'll be more. Okay. 16. N is an integer greater than 1. Prove algebraically that n squared minus 2 minus n minus 2 all squared is always an even number. So an even number is even if it's 2, 4, 6, 8, etc. So 2 times something, okay, anything is even. Remember that. Let's use this algebra now. N squared minus 2 minus n minus 2 squared. Now n minus 2 squared is n minus 2 times itself. N minus 2 times n minus 2. We've done quite a few of these in this paper, expanding out the brackets, so I'll do it quite quickly. N times n is n squared. N times minus 2 is minus 2n. Minus 2 times n is minus 2n. Minus 2 times minus 2 is plus 4. Put these guys together. N squared minus 4n plus 4. Now don't forget we had these guys as well. And actually, all of this was a negative. So we had a negative in front there, negative in front here. So let's put our negative through this, and it's going to switch the signs of everything. So plus 4n minus 4. Let's bring these guys down all the way. So n squared minus 2. Okay, now this n squared has got minus n squared there, so they're going to cancel out. Okay, the minus 2 and the minus 4 go together to give minus 6, so it's 4n minus 6. Now, remember I've said 2 times anything is even. So 2 times by something, okay, we want to know if this is even. Well, 2 times 2n gives you 4n, and 2 times minus 3 gives you 6. Okay? So anything is even. So always even. Proved it. If you've done a really good proof you're proud of, you can draw this little symbol. That means you've proved it. Okay. Question 17. There are 9 counters in a bag. You know I like diagrams, so let's not waste time. 1, 2, 3, 4, 5, 6, 7, 8, 9. 7 of the counters are green. And 2 of the counters are blue. Ria takes a random 2 counters from a bag. Okay, she's taking out 2 of these. Work out the probability that Ria takes 1 counter of each colour. you must show all your working. Now I've already thought in my head of another way you can do this, and that would be find a probability of getting two the same and take it from 1. But I want to show you the conventional way of doing it, okay, where we look at all the options. So let's say, yeah, let's use colours. So probability of getting a green is going to be 7 in 9. Okay, so getting a green first is 7 over 9. Getting a blue first is 2 over 9. Now we have to imagine what our bag looks like once we've taken stuff out of it. So if we've taken this green out, so we've taken this one, how many counters are left? Oh no. Let's ungroup that. Okay. We've taken this green guy out. So there's only 8 counters left. Okay? So these answers are going to be out of 8. And what's the probability of getting a green? Well, we've already taken one out. There's 1, 2, 3, 4, 5, 6 left now. 6 over 8. What's the probability of taking a blue? There's 2 blue left out of 8. Same one for down at the bottom. This time, we didn't take the green out. We took one of the blues out. Not both of the blues, one of the blues. Don't be too hasty there. Took one of the blues out. Again, there's 8 counters left. And we've only got 1 blue left to pick. So there's 1 out of 8. But we've got 7 green left still. 7 out of 8. So which paths are we interested in? Taking one of each colour. So it's 7 over 9 and 2 over 8. Or this. So you can get a green then a blue, or a blue then a green. In the exam, truth be told, you don't need to even draw these out in this case. Okay, just the ones we're interested in. But it's nice to have a complete picture of what's going on. So green then a blue is 7 over 9 times by 2 over 8. Okay? Because it's this and this. 7 times 2 is 14. 9 times 8 is 72. This one down here, to get a blue then a green, 2 over 9 times 7 over 8. And I know what it's going to be already, but let's go through it. 2 times 7 is 14. 9 times 8 is 72, because they're the same numbers as above. Just the other way around. Okay? Now, we can have this root or this root. So when it's or, we're going to add probabilities. So you got 14 out of 72. Add another 14 out of 72. Gives you 28 out of 72. Which is the same as 14 over 36. Which is the same as 7 over 18. Nice work. We're just divided by 2 on top and bottom each side there. Question 18. A, B, C, D is a rhombus. The coordinates of A are 5, 11. Okay, so that's across 5, up 11. Like we've said a lot. The equation of a diagonal, D to B, not incredible. Let's try that with a straight line. D to B has the equation. I just want to show you something here actually. This whole line here is what we're talking about. Okay, it carries on past it. That whole line has the equation y equals a half x add 6. The equation, find the equation of a diagonal AC. This line. I've gone off track again. My free hand has gone downhill, I'm afraid. We want to find this equation. Now, it's a rhombus, so actually these lines are perpendicular. Okay? And the gradient here equals a half. So the gradient opposite, okay, if you've got two gradients like this, m1 and m2, then m1 times m2 is minus 1. So it's a reciprocal over 1. Okay, so grad of AC equals minus 2. Now we know the gradient and we know a point. So we can use the equation y minus y1 equals mx minus x1 to find out what the equation is. Now y1, x1 is just a coordinate on the line. Any coordinate on the line. So A will do, it's on the line, and its coordinate is 5, 11. So x1 is 5 and y1 is 11. That gives us y minus 11. Remember what m is? Minus 2. Minus 2 times x minus 5. Now that is an equation for the line, but we like to write it in a nice way. So let's expand this out. Minus 2 times x is minus 2x. Minus 2 times minus 5 is plus 10. And now let's get rid of this minus 11 by add 11 to both sides. Y equals minus 2x plus 21. Great. Question 19. OABC is a parallelogram. OA is the vector A. OC is the vector C. X is the midpoint of the line AC. Okay, well let's draw that on then. So the line AC is from A to C, and the midpoint is in the middle of that line. Okay, and guess what? That midpoint is also going to be where the other diagonal crosses it. So let's put that onto a good measure. Okay, let's go dotted again, I quite like that. Let's go this dot. Oh, what a guess. Bang in the middle. Right, anyway, X is a midpoint of the line AC. OCD is a straight line, so that OC to CD equals K to 1. OCD is a straight line. Okay. So this ratio means that if you're going from O to C, like so, it's in a ratio with C to D. Okay, so say C to D is this way if K is positive, or C to D is this way if K is negative. Okay, given that X to D is 3c minus half a. Find the value of k. Right. So, here's the vector a in blue. Okay. And the vector c, let's go in pink. Right. Now I'm going to do an infinite cloner on these so that we can move them around. So a, this vector a, we can have anywhere, okay? Just means that that's how far you go and that's the angle you go. Vector c we can have anywhere, it just shows that's how far you go, that's the angle you go. We're going 3c from x, so 1. Oh, we're going to go off the page at this rate. 2, and another one right over here. 3, all in a straight line. Doesn't even fit on. Minus a half a. Okay, so this gets a bit trickier. So we've drawn on a. If we want minus a half a, we go backwards and we only go halfway. Okay, so that's about right. So we're going to go all the way over here and then back this way. And where we end up is the point on this line that we were talking about before. Okay? So D is somewhere on this green line. Okay? We're trying to figure out where. So that's the question. Now let's get down to trying to solve it. It's for 4 marks. Okay. It's the first time I've seen this question and it's making me think carefully too. Now, let's start by finding the vector O to C. Okay, so O to C is going to be what CD is. CD is. So C to D is from here to here. Okay, now if we cheat and if we go to x first and then follow x to D, then that will get us there. So we want C to x and then we want to add on x to D. And we already know what x to D is. Now C to x is minus half of C and plus half of A. Okay? So minus a half of C plus half of A. And then we go along here halfway and up here halfway. Okay, so we're going to do that and then plus xd, which is 3c minus a half a. Now can you see that our a's are going to cancel out? Plus a half a minus a half a. So all you've got left is your half minus half c plus 3c. Now 3c is 6 over 2c. So minus a half plus 6 over 2, or 6 halves minus a half, is 5 halves C. Okay, so 5 over 2, sorry, O to C, C to D is C as a ratio to 5 over 2C. Now we can divide through by our vector, and you've got one of these here, to get 1 to 5 over 2. And we want something to 1, okay? K to 1. So we need to change these. Now 5 over 2 is 2.5, or can be reversed by doing times 2 over 5. Okay, so divide by 5 times by 2. 5 over 2 times 2 over 5 is 1. So let's times both sides by 2 over 5 to get 1, and that means that k is 1 times 2 over 5, 2 over 5, which is the same as 0.4. Quite a hard question, and you can see I had to think a lot about that as well. Okay. Next one. Solve algebraically the simultaneous equations. X squared plus y squared equals 25, y minus 3x equals 13. My trick for you, if it's got the squareds in, it's not the standard linear equations to solve simultaneously. So take your easiest equation, which is this one, and make it so that it tells you what y equals, or so that it tells you what x equals. So if we rearrange this, plus 3x to both sides, then we get that y equals 13 plus 3x. Now that means that in this trickier equation, which is x squared plus y squared equals 25, we can now put what y is into the equation. Okay, so where we've got y, we're putting what y is. I'll keep the colour scheme up so you can see. So x squared plus 13 plus 3x all squared equals 25. Now we've got a bracket squared again, so we need to write it times by itself. 13 plus 3x times 13 plus 3x. And multiplying out, 13 times 13, tricky one. 10 times 13, 130. 2 times 13, 26. 1 times 13, 13, or you could have done this as 39. Gives you altogether 169. Okay. We had that before, do you remember? Square root of 169. 13 times 3x. Same again. 3x times 3x, 9x squared. 39 at 39, 78. So we've expanded this bracket with all that work. We've still got, as well as all this, the x squared and the equals 25. Okay, so x squared plus all that equals 25. So now you can combine your x squareds together. You've got 1 there, 9 there. So you've got 10x squareds. You've got 78x. You've got 169. And it added all together gives you 25. This is quite tricky too, for 5 marks. Now, if we take the 25 to this side, so minus 25 from both sides, 10x squared plus 78x plus 169 minus 25 is 144 equals 0. We've got a quadratic equation to try and solve for x. I've actually made a video showing how to solve these type of quadratic equations, and this is a particularly difficult one. Now, 10 times 144 is 1440, and we're actually looking for two numbers that multiply to make this big number and add to make 78. And then going by the method on my video, you're going to have two brackets with 10x and something else, and 10x and something else, and then a 1 over 10 outside. Now, what two numbers might add to 78 and times to 1440? Well, let's think about 144. 12 times 12 gives you 144. So 12 times 120 give you 1440. Now if we half this number and times this number by 2, then these are going to add up to 246. These add up to 132, so too big, too big. Let's double this number to get to 24, and then let's half this number to get to 60. That means their total multiplied will still be 1440 as required. But these add up to 84. Now let's try another one. Let's try 48, times it by 2 again, and 30. So these will multiply to this again, and this time they add to 78. So we chuck these guys in, plus 48, plus 30. Now this 1 over 10 we can get rid of. We can get rid of it easy enough from this bracket. So 10x plus 48 times by x plus 3 equals 0. Now we want to solve. If two things multiplied give you 0, then either this is 0 or this is 0. The simpler one, if this is 0, then x is minus 3 to make it 0. If this is 0, then we'll solve it. 10x equals minus 48. X equals minus 4.8, or 48 over 10. Okay, minus 48 over 10, which is the same as minus 24 over 5. Now, we need to use these two values that we found to find the corresponding values of y. Okay, so let's go back up to our original equations. Let's take the easy one, and we actually simplified it here to say that y equals 13 plus 3x. Okay, so y equals 13 plus 3x. We need an answer if x is minus 3. That means that y is 13 minus 9, which is 4. So that's one answer. If x is minus 24 over 5, this is a bit trickier. Y is 13 plus 3 times that. 3 times 24 well, it's 48, 68, 72, but it's a minus again. 13 is something over 5, so that's going to be, let me think, testing out my mental maths now. 13 times 5, well, 130 over 2, 65. So 65 over 5 minus 72 over 5, that means y is minus 7 over 5. So final answers are x equals minus 3 and y equals 4, or x equals minus 24 over 5 and y is minus 7 over 5. Quite a hard question. Question 21. ABCD is a quadrilateral. AB equals CD, as shown by these lines. Angle ABC, here, ABC, equals angle BCD, here. So they're the same. Prove that AC equals BD. Okay, so AC is this line here, and BD is this line here. Okay, well, if we think about this, BC is the same length, isn't it? Now these two are the same, because we've been told in the question. So if these two are the same, then what we've actually got is two identical triangles that have just been flipped over. Okay, and the triangles that I'm talking about are these two. So this guy here, let's take him out. And also this guy here. So if we manage to prove these two triangles are the same, then these two lengths are also the same. So that's what we're going to think about. Okay. So triangle ABC, it has same angle, as triangle BCD, and two sides the same. This means the third side of triangle is the same. Therefore, AC equals BD. These two must be the same because the triangles are the same, because they've shared an angle and got two lengths the same. And that is one of the conditions for triangles to be the same. Congruent triangles. Here we have it, the last question on the paper. Question 22. Well done to you if you've followed all the way through. We're at the final step. And do not be discouraged if you find this one too tricky. It's going to be a hard question. Diagram shows a hexagon. That just means it's got 6 sides. 1, 2, 3, 4, 5, 6. A, B, E, F, which is here, and C, B, E, D are congruent parallelograms. We've just been talking about congruent triangles. That means they're the same. They may have just been rotated or flipped over. Okay, AB, which is here to here, equals BC, and they both equal X, these lengths. P is the point on AF, so A to F, and Q is the point on C to D, here's Q, such that BP, so B to P, here, and BQ, here, are 10 centimeters. So that's 10, that's 10. Given that the angle ABC, which is here, is 30 degrees, prove that cos of the angle PBQ, so PBQ is the smaller angle here in the middle, equals this expression. So it looks very hard. To be honest, it probably is hard. So we're talking about angles, we're talking about proofs. We know some information might not be needed. Now, what you might see is that we've kind of got two triangles going on. We've got a triangle here. If we draw the line across, sorry, it's a bit wobbly. And in this triangle, pretend all the lines are straight. 30 degrees, x, x. And we've got another triangle here. Okay. And we know these two lengths are the same, the bases. What we don't know is the size of this angle, but we're calling it PBQ because this was P, this was B, this was Q. PBQ, and these are 10, these lengths. Now generally when you've got an angle and the two lengths either side, you're thinking about the cosine rule. The cosine rule says if you have something like this, where this is angle A, this is length B, length C, then length A opposite, then the formula is A squared equals B squared plus C squared. Looks a bit like the Pythagoras, minus 2AB cos of angle A. And this is a formula that's going to be very important in this question. So keep an eye on that guy. If we apply this formula to the top triangle, we're going to label the angle A, the opposite length little a, and B and C here. So we have A squared equals x squared plus x squared minus 2 times x, which is x squared, cos of 30 degrees. Now cos of 30 is something that you might know off by heart, and if not, I'm going to quickly show you a way to figure this out in exam. Draw out an equilateral triangle. Means that all sides and angles are the same, with all as 2. Now cut it in half. Oh, no. Cut it in half, straight as we can. And this triangle, this green one, is going to have lengths of 2 and 1 because it's been cut in half. Equilateral triangle, that was 60, that was 60, but it's been cut in half, so now it's 30. This is a right angle. Now remember SOHCAHTOA, cos is adjacent over hypotenuse. Okay, now this length we don't know yet, but if we use Pythagoras, that means that 2 squared equals 1 squared plus whatever that is squared. 2 squared is 4, 1 squared is 1. Take your 1 from both sides. Something squared gives you 3. Well, by definition, square roots of 3. So cos of 30, cos of this is adjacent over hypotenuse. Cos of 30 equals root 3 over 2. Okay, so let's simplify this a little bit, and I'll write it again. A squared, got 2 lots of x squared, minus 2 x squared times by root 3 over 2. And if we want to really simplify, That 2 and that 2 can cancel. Minus x squared times root 3. Okay, and even x squared 2 minus root 3. And look, we're starting to look a little bit like this answer. Now let's think about our other triangle in the question. Let's apply the cosine rule to this one too. We get the A is the same here. Angle A, length B, length C. A squared equals 10 squared plus 10 squared minus 2 times 10 times 10 cos of PBQ. So A squared is 200, 100 plus 100 minus 200 cos PBQ. Now we want our answer to be cos of PBQ, so we need to rearrange, but we're not quite ready to rearrange. We need to equate this A squared and this A squared. So if that equals that and that equals that, then this whole thing equals this. X squared 2 minus root 3 equals 200 minus 200 cos PBQ. Let's factorize the 200 out. 201 minus cos PBQ. Let's divide by 200. X squared 2 minus root 3 over 200 equals 1 minus cos PBQ. And that means that cos PBQ equals what we wanted, which is 1 minus 2 minus root 3 over 200 x squared. Okay. Right, so quite tricky question at the end. I don't imagine everyone will follow that. Ask some questions if you want, and make a comment, like the video. If you like what I've done, I'll be posting some more videos, so keep a lookout. Make sure you subscribe. I've also written a book. My book is called How to Achieve in Maths, and it's really going to help you get those top grades. I've made up questions that are unique and will help you to do really well in the exam. So it's called How to Achieve in Maths. It's on Amazon. You can buy it on Kindle, and you can buy it from my website, achievemaths.co.uk, and there'll be a link on there.